right, here is sample question one. This is a kind of a question you may likely see. I'm not saying this is a question, but a kind of question you may likely see in your Waec practical exam. All right, so now let's go over to it quickly. An is 0.10 mole per dm cube of HCl. This is the concentration of the acid. Then B is a solution containing 5 grams per dm cube of this compound here. All right, the dehydrate. Now we have S here as an unknown variable, which we will be asked to look for. And then, as usual, put A in the burette and titrate it against 25 cm cube or 20 cm cube portion of B using methyl orange as indicator. Tabulate your readings and calculate the average volume of acid used. Then from your result and the information provided above, calculate concentration of B in mole per dm cube, molar mass of Bn, value of S, then the percentage mass of S in this compound. All right, now for you to do that, let's start with the first one, which is the concentration of Bn. Now take note, we have the concentration of acid here as 0.102 mole, while we are asked to look for Bn, and that's the aim of the titration, to determine the concentration of an unknown solution using the concentration of a known solution, a known volume. All right, now you can get that using the formula method. Though we have a lot of method, but for simplicity, let's use the formula method, which is CaBa over CbVb equal to Na over Nb. All right, so now ensure that when you want to write or you solve in your exam, don't miss any step. We don't just go and fill in the parameters, the figures into it. Ensure you state them out before you go further into your calculation. All right, so if we have that now, we see our C is the concentration of the acid, which is 0.102 mole per dm cube. Our Va is the volume of acid, which is 8.55 cm cube. This is the average volume of acid used from your calculation. We did that in my previous video, and look at it. This is the average volume of acid used from the calculation, size of pipette and indicator used, and this is the Va we got from our calculation. All right, so let's go further. Our Cb is the concentration of the base, which is unknown, and Vb is the volume of the base, all right, which is 25 cm cube. It's gotten from the size of your pipette, 25 cm cube. So those of you using 20 cm cube pipette, ensure you state 20 cm cube here. All right, then Na, number of moles of acid. Check it, the acid here, the number of moles is 2. All right, so we have 2, while the base number of moles Nb is 1. All right, so we'll go over to substitute the parameters into the equation. Ca is 0.102 mole per dm cube times Va 8.55 cm cube times 1 over Cb, which is unknown, times Vb, which is 25 cm cube, okay, equal to Na. Na is 2 over Nb 1. So to get Cb, we cross multiply. So if you cross multiply, you should be having 0.102 mole per dm cube times 8.55 cm cube times 1 equal to Cb times 25 cm cube times 2. So to make Cb the subject of the formula, we'll divide both sides by the coefficient of Cb. All right, so sorry, that should multiplication. So dividing both sides by the coefficient of Cb, we should have Cb is equal to 0.102 mole per dm cube times 8.55 cm cube times 1 over 25 cm cube times 2. All right, so if you take note, cm cube cancel cm cube here. So if you multiply this with your calculator, which we should do now, that is 0.102 times 8.55. All right, 0.8721. So that's it. 0.8721, 0.8721 over 25 times 2 gives you 50. So now let's divide to get the answer. 0.8721 divided by 50. So the answer is 0.0174. So our CB, consider of the base, is 0.0174 mole per dm cube. So this is the concentration of the base. Take note of that because we're going to use it for further calculation. All right. So let's go over to the next question, which is we should calculate the molar mass of the basic salt, the molar mass. So to do that, here's what you do. Molar mass of S2CO3 dot 10 H2O. Now take note, the mass here is S here is an unknown element, so you cannot just calculate the mass by summing everything here together. All right, so whenever you have issue like this where you have an unknown variable, you use this formula to calculate the mass of the compound, which is concentration in grams per dm cube is equal to the concentration in mole per dm cube times molar mass. All right, take note, we are looking for the molar mass, so we make molar mass the subject of the formula by dividing with concentration in mole per dm cube. All right, concentration in mole per dm cube. So once this one goes through this one out, we have molar mass is equal to the concentration in grams per dm cube time over the concentration in mole per dm cube. All right, so now what's the concentration in grams per dm cube? You can get that from the question. It's given to us for Bn, that Bn contains 5 grams per dm cube, 5 grams here per dm cube. So that's the concentration in grams per dm cube. All right, so we have it here as 5 grams per dm cube. All right, and take note, your molar mass is in grams per mole, grams per mole. Then the concentration in mole per dm cube of the Bn is what we calculated to be this. All right, 0.0174. So you divide it with 0.0174 mole per dm cube. All right, so let's do this and get the answer now. Guys, 5 divide 0.0174, 287 approximately. So the molar mass of the compound is 287. Look at the grams per mole, grams per mole as the molar mass. All right, so now let's go over to the next question, which says calculate the value of S. All right, calculate the value of S. Now to calculate the value of S, this is how you do it. You equate to the molar mass. The formula for the compound, this is the II. The formula for the compound is S2CO3.10H2O. All right, you equate it to the molar mass you have, which is 287. All right, so now let's substitute the individual masses into it and make S the subject of the formula, and you can get it. Calculate the relative molecular mass of this. S is unknown, so 2 times S gives you 2S plus mass of carbon. All the mass will definitely be given to you in the question, and you can see the mass of sodium 23, carbon 12, oxygen 16, hydrogen 1, and chlorine 35.5. Okay, so we have for carbon to be 12 plus oxygen is 16. All right, 16 you multiply with 3, but we have 3 there. 3 plus water plus it plus 10 water. 10 multiply water. Hydrogen is 1. 1 times 2 gives us 2 plus oxygen is 16. All right, equal to 287. So we have 2s plus 16, 12, 16 times 3 gives you 48 plus 10, 2 times 16 will give you 18. All right, equal to 287. All right, so now let's go further to sum all these 12 plus 48 plus this one. We have 12 plus 48. 10 times 80 will give you 180 equal to 287. So we sum all this together. If you do that, this is what you should get. That is 12 plus 48 plus 180 gives you 240. All right, so we have 2s equal to 240. Sorry, it's a plus here. All right, 2s plus 240 equal to 287. All right, to get 2s, we'll take like terms. It becomes 2s equal to 287 minus 240. All right, 287 minus 240, that is 287 minus 240. We have 47. 47. So divide both sides by 2 to get s. All right, 47 divided by 2. Let's go. 47 divided by 2. We have 3.5. So our s is 23.5. So s is equal to 23.5. All right, as s. So now you should know that the element that has this mass approximately is sodium. So s is sodium. All right, in case you're asked to say what s is. So we'll go over um to the okay, we've calculated value of s. All right, so all right, now the percentage mass of s in this compound. So that's the next one we're doing, which is the last one, IV, percentage mass of S in S2CO3 decahydrate. All right, so to do that is normal percentage mass composition, the mass of the substance over the total mass, the mass of S, mass of S over the total mass of the compound, total mass times 100 over 1. All right, so what's the mass of s? It is, we got it to between 3.5 and 3.5. Take note, we're having 2s, so we multiply by 2. All right, over the total mass of this compound, which we've calculated, the total mass with the relative molecular mass as 287 times 100 over 1. If you multiply these two together, you have 47. So it becomes 47 over 287 times 100 over 1. All right, so you divide that and let's see what we have. Okay, 47 divided by 287. We have this times 100. So we have the percentage to be 16.37%. All right, so yes, sample 2 question you may likely see in your exam. So it's quite much. It says AN is a solution containing 0.102 mole per dm cube, while BN contains 5 grams per dm cube. But now take note, the other one we did, S in place of sodium was omitted, but now here we have S here, and S here is omitted. So what we should be looking for here is the water of crystallization. Take note, whenever you are asked to look for that, you are having a substance like this, and S in the water oxidation is given as unknown. You should take note of this, that when both of them, the HCl, react with the sodium carbonate decahydrate, it is the anhydrous part of it that reacts with the acid. The water do not take part in the reaction. It's just present in the solution as impurity. So please take note of that. I believe someone asked me that question in my YouTube video, the previous one. I have to answer that question there. You can check the comment there, and please ensure you subscribe to this YouTube channel, because more interesting videos will be coming your way soon. All right. So as you put A in the burette and titrate it against 25 or 20 cm cube portion of B using methyl orange as the indicator. Tabulate your readings and calculate the average volume of A used. Now from your results, calculate amount of HCl, that's the amount of HCl in the average volume of acid used. Now take note, sometimes you will say calculate amount. Sometimes instead of them using amount, you will say calculate the number of moles of HCl. All right, both of them are same. Okay, so now let's go over to calculating the first one. The first one is we should calculate the amount of HCl in the average volume of acid used. Take note, in the average volume of acid used. Now, how do you do that? This is how you do it. Very simple. Take note, our average volume of acid used, VA, is 8.55. All right. And the same, we should calculate the amount of HCl in the average volume of acid used. All right. So for you to calculate the amount, here's the formula I use, a very simple formula, which is concentration is equal to amount in moles. Take note, amount is calculated in mole over volume. All right, this is just the definition of concentration, because we have to do with amount of a substance per volume of solution. All right, so we are looking for amount. We make amount subject of the formula by saying amount is equal to concentration times volume. Take note, your volume is in dm cube. All right, now let's go over to state our parameters. Now, what's the concentration of the acid? Concentration of the acid, which is HCl, is 0.102 mole per dm cube. All right, now what's the volume? The volume of the acid we use in the pipette, in the average titrate, is 8.55 cm cube. All right, so we have 8.55 cm cube. Take note, volume is in dm cube, so we divide 8.55 with 1000. All right, so if you divide 8.55 with 1000, that's 8.55 divided by 1000. We have it as 0.00855. All right, take note of that. So dm cube. So now let's substitute into it. Amount is equal to concentration, which is 0.102 mole per dm cube, times the volume, 0.00855 dm cube. All right, dm cube is cancelled dm cube. So now let's do this and let's get the amount. That is 0.102 times 0.00855. All right, we have the amount 721. All right, 8721. So mole, take note, this is the what amount. That's how it is being calculated. All right, now let's go to the next one. It said calculate the concentration of Bn in mole per dm cube. Concentration of Bl, take note, concentration of the acid is given So we can use it to calculate the concentration of the BN as explained in the first example, which is CaVa over CbVb equal to Na over Nb. All right, you know your Ca to be 0.102 mole per dm cube. Your Va is 8.55 cm cube. Your CB is unknown, what we are looking for. Your VB is the size of your pipette you use, 25 cm cube. Your Na is the number of moles of acid, which is 2. Nb is 1. For those of you that don't get it, you can get it here. Number of moles of acid, 2. Number of moles of the basic salt is 1. All right, so if you substitute this into the equation, we have 0.102 moles per dm cube times volume, which is 8.55 cm cube, over consider of the base times 25 cm cube equal to 2 over 1. All right, so if you make Cb the subject of the formula, you have Cb equal to 0.102 moles per dm cube times 8.55 cm cube over 25 cm cube times 2. If you do your calculation, you should have Cb to be 0.0174 mole per dm cube as the concentration of the base. All right, so go back to the next question, which is calculate the um, amount of Bn in 25 cm cube pipetted. All right, in the 25 cm cube pipette, amount of Bn in the 25 cm cube pipette. All right, that's very simple. Amount which we did for the acid, amount of Bn in the 25 cm cube. All right, as usual, formula concentration is equal to amount in mole over volume in dm cube. All right, so our concentration of the Bn is what we just calculated to be 0.00174 mole per dm cube. Amount, we're looking for amount over volume is 25, so you convert 25 to dm cube, is it cm cube, that is 25 divided by 1000. All right, so if you divide 25 1000, you have 0.025 dm cube. All right, so here we have 0.025 dm cube. So amount, cross multiply now, amount is equal to 0.0174 mole per dm cube times 0.025 dm cube. All right, dm cube will cancel dm cube. So now let's multiply both of them and get the answer. 0.0174 times 0.025. So we have 0.000435, 0.000435 mole. All right, 435 mole as the amount. So, all right, move over to the next one. We should calculate the mass of anhydrous Bn, mass in grams per dm cube. Take note, mass of anhydrous Bn. Okay, now take note, the Bn, which is your basic salt, contains water of crystallization, which is Na2CO3 dot SH2O. All right, this part of it is the anhydrous part, while this is the water of crystallization. So now we have to calculate the amount of the anhydrous. All right, this anhydrous, the side without the water. Okay, the mass, which is the formula, this formula use concentration. All right, in grams per dm cube is equal to concentration in mole per dm cube times molar mass. All right, so we want to calculate the mass of the anhydrous, which is mass is in grams, okay, per dm cube. So we equate it concentration in grams per dm cube is control of mole per dm cube of Bn, which we calculated to be 0.0174 mole per dm cube times the molar mass of the anhydrous part, which is, take note, the anhydrous part here, we are having Na2CO3. Sodium is 23, the mass of sodium is 23. Mass of sodium is 23 times 2 here, we're having 2 here, plus carbon is 12, oxygen is 16 times 3, 16 times 3. When you sum everything together, you have 106 as the mass of it. 106. Okay, so we have it here 106 grams per mole. Grams per mole. Okay, so when we sum everything together, let's quickly do that. Perhaps 0.0174 times 106. All right, it gives you 1.84. Let to three significant figure. So 1.84 grams per dm cube. This is the mass of the anhydrous part, the mass of the anhydrous part of it, which is Na2CO3. Take note, the mass of it is 1.84 grams. All right, so we'll go further to the next question here, which says calculate the mass of water of crystallization. Take note of this, calculate the mass of water of crystallization. Now look at this. That should be question number 5. Mass of water of crystallization. Okay, now if you look at the compound very well, Na2CO3 dot XH2O. This is the mass of this, the anhydrous part. Now the question says Bn contains 5 grams per dm cube of this, 5 grams. So the total mass of the compound will dissolve per dm cube is 5 grams. And the mass of the anhydrous part we just calculated is 1.84 grams. Now, so we should calculate the mass of water of crystallization. So to get mass of water of crystallization, is just to subtract the 5, the 1.84 from the word 5. Okay, so the mass of water of crystallization is equal to 5 minus 1.84. All right, so 5 minus 1.84, 5 minus 1.84, we have 3.16. All right, so mass of water of crystallization is 3.16 grams. This is the mass of the water of crystallization. I believe that's very clear. Okay, so we'll go back to the next one. Calculate the molar mass of this, the molar mass of the unknown compound. The molar mass, that is VI rather, molar mass of Na2CO3 dot XH2. Now take note, you cannot just sum all the molar mass together because S is unknown. All right, so I say whenever you have issues like this, you use the this formula, concentration in grams per dm cube is equal to concentration in mole per dm cube times molar mass in grams per mole. Okay, so the concentration in grams per dm cube, we already have it to be 5 from the question. If you check the question very well, considering the concentration in grams per dm cube is 5 here. All right, so we have it to be 5, and 5 grams per dm cube. Then the concentration in mole per dm cube of the Bn, we calculated it. You've been following, we calculated it to be 0.01 0.74 mole per dm cube, all right, times the molar mass. The molar mass is what we are looking for, so we divide both sides by the coefficient of the molar mass, which is 0.0174 mole per dm cube over 0.0174 mole per dm cube. All right, so when you do this, you should be having your molar mass. Your molar mass is equal to 5 grams per dm cube divided by 0.0174 mole per dm cube. All right, so let's divide this 5 divided by this. If you do that, you should have 287 grams per mole as the molar mass. All right, so we go over to the next question. The value of S. What is the value of S? All right, which is V VII. What is the value of S? VII, the value of S. Take note, that is from your formula Na2CO3 dot S. We should look for the value of X. To get the value of S, we equate to the molar mass, which we just calculated to be 287. 287. Okay. Now let's get the relative molecular mass of all the individual elements here and then make S the subject of the formula. Now, how do you do that? Take the mass of all individual elements will be given to you in the question. You look at sodium 23, carbon 12, oxygen 16, hydrogen 1, and chlorine 35.5. Okay, so when you substitute their individual mass into it, sodium is 23 times 2, we're having 2 of it there, plus carbon is 12, plus oxygen 16, and we have 3 of it times 3, plus we're looking for S, and hydrogen is 1 times 2 give us 2, plus 16, which is oxygen. 2 plus 16 gives you, if you plus them, gives you 18. So let's just place the 18 there. 18 equal to 287. So 2 times 23 will give you 46, plus 12. 3 times 16 will give you 48, plus S times 18 will give you 18S equal to 287. So now let's sum all these together first. So if you do that, we have 46 plus 12 plus 48. All right, we have 106. So here we have 106 plus 18S equal to 287. We'll take like terms to be 18S equals 287 minus 106. All right, so 287 minus 106, 287 minus 106. We have 181. So we divide both sides by 18. So 181 divided by 18. 181 divided by 18. We have 10, approximately 10. So 10 is the value of S. So you can rewrite your formula to be Na2CO3.10H2O. I believe this is very clear. All right, now let's go over to the next question. Next one here, it says, what is the percentage of water of crystallization? The percentage of water of crystallization. So to calculate the percentage of water of crystallization. Now the water of crystallization we calculated from the question. If you check very well, the water of crystallization, which we have here, mass of water of crystallization, it is 3 0.16 from the total mass, which is 5. So the percentage of water of crystallization, it is the percentage of the water of crystallization in the equation 1.16 over the total gram, which is the 5 grams of Bn, all right, times 100 over 1. So let's divide that, which is 3.16 divided by 5, all right, times 100. We'll have it to be 63.2%. So this is the percentage of water of crystallization. All right. So we'll go back to the next not the final, the IS, which is volume of CO2 that will be liberated at STP, the volume of CO2 that will be given off at STP. All right, this is mass volume relationship. Okay. IX, the volume of CO2 liberated at STP. All right, you can get this from your balance equation. Now, from the equation, we say we have 2 moles of this reacting with Na2CO3 XH2O. All right, to give you sodium chloride plus water plus carbon dioxide plus the water of crystallization in it. All right, now the stoichiometric relationship is between this compound and this one. All right, said if you react these two together, what volume of CO2 is given off? All right, so you can get the relationship between both of them. Now we're having you can use a mole volume relationship here. Here we have 1 mole of the Bn. 1 mole from the equation is given out what volume of gas. Take note, this is 1 mole of CO2 gas. 1 mole of CO2 gas. And from your gas laws, you should know that 1 mole of a gas occupies sorry occupies 22.4 dm cube. All right, so 1 mole is liberating 22.4 dm cube of CO2. Then from the equation, from the reaction, we used 0.0174 mole per dm cube. This is the concentration of the Bn, and this is the volume we use, 25 cm cube. All right, now let's convert this one to mole and get what amount it will give out. All right, I believe you're with me. 1 mole will give out this. Then from the practical, this is the concentration of the base and this is the volume of the base. So what is the mole equivalent of this? You can get that using your concentration is equal to amount over volume. All right, now concentration is 0.0174 equal to the amount. All right, we're looking for amount, which is amount is also mole, number of mole. All right, over the volume 25. If you convert 25 cm cube to dm cube, take note volume is in dm cube. Wow, 0.025. So when you multiply both together, which is 0.0174 times 0.025, 0.000435, 0.000435. So if 1 mole, take note 4335 mole. So if 1 mole of this from the equation, the stoichiometric relationship of the equation, 1 mole of this gives out this gas, then 0.000435 mole, which we use for the titration, will give out what volume of gas. All right, you cross multiply 1 times S gives you S, then 0.00435 times 22.4, that is 0.00435 times 22.4. So S becomes let's multiply that together, 0.000435 435 times 22.4. All right, we have 0.009744, 0.009744 dm cube, dm cube of CO2 being liberated from the world equation, from the reaction, from the titration, rather. All right, so we're almost there. Go back to the last question, which says calculate the mass of sodium chloride that will be formed in the reaction. The mass of sodium chloride formed in the reaction. All right. So here's how we calculate it. From the equation 2HCl plus our N2CO3 dot SH2O reacts to give you sodium chloride plus water plus carbon dioxide and our water crystallization. All right. So now, he said, what is the mass of sodium chloride that will be formed in this reaction? First, let's get the stoichiometric word relationship between both of them. All right, between the masses here. All right. If you calculate very well, you have your limiting reactants, and that's why I'm using this one. So let's go over to that. So the mass of this, which we've already calculated from our previous calculator, is 287. That means 287 mass of this is giving us what mass of sodium? Let's calculate the mass of sodium chloride. Mass of sodium chloride, the molecular mass relative, the formula mass of sodium chloride. Okay, so sodium is 23 and chlorine plus 35.5. Take note, we're having 2 moles of it, so multiply it with what? 2. All right, so now um, let's multiply that and get the answer. 23 plus 35.5. We have 58.5, so times 2. We have 117. 117, so 117 grams. So from the stoichiometric relationship, so we are looking for mass of Na. That's why I'm using mass relationship. The mass of sodium carbonate dihydrate in the equation will give you 117 grams. All right. So now what mass will be formed from the titration? Now this is how you get the mass. Take note, from the titration, this is what we use as the base. We use a quantity of 0.0174 mole per dm. This is the concentration of the BN I'm using here, and this is the volume also 25 cm cube. Now, what is the mass equivalent of this? Because I'm doing mass relationship. 0.0174 mole per dm cube of 25 cm cube. What mass does it contain? All right, the 25 cm cube with this concentration, what mass does it contain in it? It's a very simple thing. You use concentration equal to mass over molar mass times 1000 over volume. All right, concentration we have here is 0.0174 mole per dm cube is equal to the mass, is the mass we are looking for, over the molar mass of the Bn is 287 grams per mole times 1000 over the volume is 25 cm cube. Okay, to dm cube. So okay, our mass is unknown, which is S. So we want to make S subject of the formula, and these are, you can do that as a very simple calculation. That is 0.0174 mole per dm cube is equal to our mass S, that is S times 1000. Let's say we have 1000 S, okay, 1000 S over 287 times 25. 287 times 25. 287 times 25. We have 7175. 7175. All right. We cross multiply. If you cross um multiply, or let's look at this one first. Milligram per mole. If you cross multiply, we have 1000 S is equal to 0.0174 mole per dm cube times 7175 grams per dm cube. Okay, so let's multiply both of them together now. That is 0.0174 times 7175. We have 124. Let's just say 125, approximately 125. Okay, so we have 1000 S equal to 125 grams per mole. So we divide both sides by 1000. So you divide it by 1000, you should have 0.125. That is 1000 divided by 1, sorry, okay, that's 125 divided by 1000, 0.125. So 0.125 grams per mole. So this is the mass equivalent. This is the mass 0.125. You are in this solution of concentration and volume. All right. So it is 0.125 grams. So from the equation, if 287 grams of this gives 117 grams of this, 0.125 will give take note, this 0.125 is the mass equivalent of this. The mass contained in 25 cm cube of this is 0.125 grams. All right, so now let's make SW formula. 287 times S will give you 287S. Then 0.125 times 117, 0.125 times 117 gives you 14.625. 14.625. Or I will divide both sides by 287 over 287. 287 to get S. All right, so when you do that, that means 14.625 divided by 287. You have 0.05. All right, let's just say 0.05 51 0.051 grams of salt of sodium chloride is formed in the equation. So here's the last sample question we may likely see in the 2023 Waec practical question. So it says AN is a solution containing 1.86 grams of HCl in 500 cm cube. BN contains 1.25 grams of sodium carbonate S hydrate per 250 cm cube. All right. Now, as usual, put A in the burette and titrate with 25 cm cube or 20 cm cube of B using methyl orange as your indicator. And tabulate your readings and calculate concentration of AN in mole per dm cube, concentration of BN in mole per dm cube, molar mass of this, and value of S. All right. So I will do the first two and give you the other ones as assignment. You do it and drop it in the comment section below. Okay, so now let's go. The first one is calculating the concentration of AN in mole per dm cube. So how do we calculate concentration of AN in mole per dm? Take note, we are given mass and we are given volume. All right, so long as we have the mass and the volume, we can calculate the what concentration of the acid using this simple formula, which is concentration is equal to mass in grams over molar mass in grams per mole times 1000 over volume. All right, so we want to look for the concentration is equal to the mass. What's the mass? 1.86 grams. 1.86 grams over what's the molar mass of HCl? To calculate the molar mass of HCl, all right, hydrogen is 1, chlorine is 35.5. All right, you sum them together, you have 36.5. So 36.5 grams per mole times 1000 over what's the volume? 500 cm cube. 500 all to km cube. So if you do this, 1.86 divided by 36.5, 1.86 is 1.86 divided 36.5 to have 0.05095. All right, 1000 divided by 500 is 2, so multiply times 2. We have 0.102 approximately as the concentration. 0.102 mole per dm cube. All right, I think that's very clear. So we can also go further to go for the next question. Concentration of Bn in mole per dm cube. So long as we've gotten the concentration of one of the solution here, which is the acid, we can use it to look for the concentration of the Bn, which is the aim of the titration, to determine the concentration of the unknown solution using a solution with a known concentration. All right, so that's the II, which is concentration of Bn. We use our CAVA over CBVB equal to NA over NB. So you state your parameters and ensure you do that. Your CA is what we got here to be 0.102 mole per dm cube. Sorry, it's raining here. And your VA is 8.55 cm cube. Your CB is what we're looking for. Your VB is 25 cm cube. And your Na, number of moles of acid, is 2. NB is 1. So you substitute into the equation. Ca will give you 0.102 mole per dm cube times 8.55 over Cb times 25 equal to 2 over 1. If you make Cb the subject of the formula, you have 0.102 mole per dm cube times 8.55 all over 25 in cm cube. Take note, cm cube, times 2. So when you do that, your Cb becomes 0.0174 mole per dm cube. All right. We should continue with the third question here, which is the molar mass of our Bn, which is sodium carbonate S hydrate. To calculate the molar mass, so to do that, as usual, we use our concentration in grams per dm cube is equal to your concentration in mole per dm cube times molar mass in grams per mole. All right, so we're looking for the molar mass. So make it the subject of formula by dividing the coefficient of molar mass, which is your concentration in mole per dm cube. So if you should divide with concentration in mole per dm cube over concentration in mole per dm cube, you have molar mass is equal to the concentration in grams per dm cube over your concentration in mole per dm cube. Okay, so what's then your concentration in grams per dm cube? You can get that from the question. It says Bn contains 1.25 grams per 250 cm cube. Take note of this. All right, 1.25 grams per 250 cm cube. That means we're having 1.25 grams per 250 cm cube. All right, so now let's substitute. But take note, your concentration here is in grams per dm cube. That is grams per dm cube, which is 1,000 cm cube. But here we are having 250 cm cube. So now let's calculate the mass we'll have in 1,000 dm cube. All right, because our formula here says per dm cube. So if we have 1.25 grams in 250 cm cube, how many grams are we supposed to have in 1,000 cm cube? All right, so we cross multiply 250 times s gives you 250 s, and 1.5 times 1.25 times 1,000, that is 1.25 times 1,000. All right, we're having 1,250. So we divide both sides by 250 over 250 to get S. So if you divide, you should have 1,250 divided by 250. So the answer will be 5. So we have 5 grams per dm cube. All right, take note. So we can go further to substitute into our equation, which is molar mass equals to 5 grams. All right. Now the concentration of the Bn in mole per dm cube is what we've calculated to be 0.0174 mole per dm cube. All right. So take note, we have this grams per dm cube. So if we divide now 5 divided by this, that is 5 divided 0.0174, we have 287. So 287 grams per mole, that's the molar mass of it. So that's for that. We'll go over to the last question here, which says calculate the value of S. So I will leave you to do that, at least for my explanation, my comprehensive explanation so far. You should be able to do this. So when you've gotten this, you can drop your answer at the comment section below. Thanks for watching. Thanks for watching, and please do subscribe to my YouTube channel. I greatly appreciate that. Thank you.